So I can't call them both theta, so they're just two different answers. Give me a unit circle value. Any one you want. Okay, so we want to know, does sine of pi over 4, I don't know why I'm doing this in pencil, plus, give me another unit circle value, pi over 6. Does that equal sine of pi over 4 plus sine of pi over 6? So the question really we want to know is, can I just distribute this sign? Just like we usually do with brackets. Can I apply it to the pi on 4 and can I apply it to the pi on 6? So let's do the right-hand side first because it's a little bit easier. So we know these are unit circle values. What is the sine of pi on 4? And what is the sine of pi on 6? And how do we add fractions? Which they already have, and what do we do with the tops? Just smush them together, root 2 plus 1. And I want you to grab your calc and tell me approximately what is that equal to. So let's go to 1 decimal place. Let's go to 2 decimal places. I just spelled that all over my phone. See what your accuracy did. That was very accurate on my phone. Sorry, it is. Can someone confirm? 1.21 if we go to 2 decimal places? Can someone confirm that value? Can we write that down? No, no, this is just a sign value, so it's just a value. 1.21, did I remember that correctly? So how are we going to show they're the same? Well, now we're going to go to the left-hand side. If we can eventually get it down to 1.21, then we've proven this is true. Heads up, it's not true. Okay, so now we got to combine these within the brackets first. Common denominator of 4 and 6. 12. How do we turn 4 into 12? What do we multiply by? So pi times 3 is 3 pi. And how do we turn 6 into 12? Times 2, so 2 pi on the top. And then we just add them together, which gives us 5 pi on 12. And so plug that into your calc. Make sure that you're in rads. So you're going to do sine 5 pi divided by 12. I already know it's not going to equal because we know this has to be less than 1. So I already know it's not going to be good down here. Do we have a value? Sorry, 0.97. Confirmation. And the point of this was to prove you can't distribute a function. You can't just multiply a function through. If this was a number, we could do that. But you can't distribute a function. I'm going to repeat that again in case you want to write that down. You cannot distribute a function. You cannot distribute a function. Your brain's going to want to, because we've trained it. If there's something in front of brackets, multiply it through. Well, that doesn't work when it's a button on your calculator. It's like a square root you can't distribute through. A square you can't distribute through. Okay, well, let's look at this. Is sine of 30 plus 60 equal to the sine of 30 times cos of 60 plus cos of 30 plus sine of 60? And you're like, what? How can those be the same? Well, let's prove it. Let's go to the left first because it's the easier side. So we're going to do exactly what we did up here. Let's add in the brackets first. So 30 plus 60 is 90. What's the sine of 90? So we're at the top of the unit circle. Ooh, I heard 3 answers at the same time. 1, I think we agree it's 1. Okay, so if we can get now all this stuff on the right-hand side to equal 1, then we know this is true. Okay, so sine of 30 is like sine of pi on 6. So what's the sine of pi on 6? Offer of 1 over 2. Okay, 60 is like pi on 3. So what's the cos of pi on 3? 1 over 2. Cos of 30 is like cos of pi on 6. Root 3 on 2, I think I heard. And the sine of 60 is like the sine of pi on 3. Root 3 on 2. And you're like, how is that going to equal 1? Because math is pretty. This is a multiplication. This is a multiplication. This is an addition. What do we have to do first? The multiplications. Top times top, bottom times bottom. Offer of a quarter. Second multiplication, top times top, bottom times bottom. Confirm. Okay, how do we add fractions? Four divided by 4. Oh my God, how does that equal? How does all of this stuff equal that? Well, because that's a new formula we're going to look at. This is called a sum identity because we're adding two angles. We're also going to look at what's called the difference identities when you subtract them. Here's new formulas. So we write the sum and difference identities together just because mathematicians are lazy and we don't want to write formulas twice. So the top is when we're adding, the bottom is when we're subtracting. Adding, subtracting, adding, subtracting, and I'll show you the other side in a second. I'm going to go sine first because that's the one that we just proved, and we just proved that sine alpha plus beta, what? Greek letters? What is that? What is alpha and beta? They're just two angles. We can't call them both theta, and in English we probably would have called them x and y, except we're using Greek because the Greek invented this. So instead of using theta, we just pick the first two letters of the alphabet, alpha and beta. Okay, alpha looks like this when you draw it. It is not a fish. It does not have a tail. There's no eye. It's not a Jesus fish. It's an alpha. This is a character. Beta looks like our capital B, except it's got a long tail on it. It's not a little English B. It's not a regular B. It's a beta. That's a symbol. Okay, so this is a fish, not an alpha. Okay, so we just proved that sine alpha plus beta equals sine of alpha times the cos of beta plus cos of alpha times the sine of beta. I know you want to draw fish because it's what you're used to drawing. It's not an infinity, it's not an 8 on its side, it's an alpha. And you're like, what? How did we just prove that? Well, I'll flip back, you keep on the same page. Imagine that this was alpha and this was beta. Just two different angles is all it means. Look what we have on the left-hand side. Here's sine of alpha, cos of beta, cos of alpha, sine of beta. And we prove they're exactly the same. Okay? The point of this is you can't just distribute a function. You can't say this is cos of alpha or sine of alpha plus sine of beta. It doesn't work that way. If I want to do alpha minus beta, all it means is that this turns into a minus. So in the other class, some people were confused with that plus and minus. If you want to write it as two different formulas, if that works better for your brain, then write it as two different formulas. So if you want to write the minus one underneath, it's sine alpha, cos beta, minus cos alpha, sine beta. And then you can just ignore the negatives here if that works better for your brain. Again, mathematicians, we tend to clump them because we're lazy. So it actually is two different formulas, we just smush it together. Cos alpha plus beta, again, we can't just distribute this cos and say it's cos of alpha plus cos of beta. It doesn't work that way. The formula for alpha plus beta is cos of alpha times cos of beta. And then when you're adding on the left, you're subtracting on the right. And you're subtracting sine of alpha times sine of beta. So it's cos alpha, cos beta, minus sine alpha, sine beta. And you'll notice it's close to the cos one or the sine one. They're just a little bit different. And we could prove that as well. We're not going to for the sake of time. If this happens to be a minus here, so we're subtracting, what happens over here? It becomes an addition. And again, if your brain doesn't like that, then write underneath the second formula, which is just cos alpha minus beta, and fill in the other side. So if you don't like the combining, then just do them separately. It's subtracting, it's adding. So the sine ones are the same, and the cos ones are opposite. Tan also has a formula, so again, we can't just distribute a tan. We can't say this is tan of alpha plus tan of beta. It doesn't work that way. We'll do the plus formula first. It is equal to tan of alpha plus tan of beta, which looks like we just distributed, except there's a denominator, which is 1 minus tan of alpha times tan of beta. So if it's a plus on the left, it's a plus on the top and a minus on the bottom. If it's a minus on the left, this turns into a minus and this turns into a plus. And again, if your brain's like, what is she doing? Just write it under here. This would become tan of alpha minus tan of beta over 1 plus tan alpha tan beta. Why do we call these sum and difference identities? So what does sum mean? What does it mean when you take the sum of something? You're adding it. And what does it mean when you find the difference of something? You're subtracting. It's because there's adding and subtracting on this side. Okay, these are going to go on the front of your new card, or you're going to squish them somewhere on your old car, so wherever you like them. You can write them with the plus and minus, or you can write them as 6 different formulas, whatever works better for your brain. They're going to go on the back of the new card. So this is all you have on the front of it. Positive, positive, minus, negative, negative, positive. This is all that will go on the front of your new card, so feel free to space them out. Okay. Tomorrow we're going to use the back of the new card. If you're working on your first card, just squish them in there somewhere. Someone is going to do it. Okay, so what do we do if we can't distribute? Well, we grab our card. You look at cos angle minus an angle. That's just an alpha minus beta. So what is the other side of the sine alpha minus beta equation? Sine alpha cos beta minus cos alpha sine beta. Well, what is alpha? What's the first angle they've given us? So they didn't give us alpha and beta. What did they give us as the first angle? Theta. So I'm just going to replace alpha for theta. And what is beta? What is the second angle that they gave us? Pi over 2. The reason I bracketed this is because it's not mathematically correct to say these are the same. But if you like to have this in order to match your alpha and betas, have it. Brackets means to the marker, just ignore this. So we don't look at stuff like this in brackets. Ideally, you can jump straight to here, but if your brain can't, no big deal. You're just going to put this in brackets to say, look, I know this isn't quite the formula. I'm just using it to get this. Cos pi on 2 is a number, and sine pi on 2 is a number. So we're going to put those numbers in right from the unit circle. Top of the circle, what's the cos value? 0. Top of the circle, what's the sine value? I've got a multiplying, and then a subtraction, and then a multiplying. What do I have to do first? The multiplying. Sine times 0. Minus cos times 1. What's 0 minus cos? Ah, what do we see? Quit. Although the sum and difference formulas are scary and they're long, these are usually some of the easiest identities to solve because they always happen like this, that there's a 0 usually somewhere and it cancels right down. In terms of the math, all you would really need are these steps, so they are like 2 to 3 step identities. What does exact value mean? No calc, no decimals. So this is like a question from last semester. Last unit, we did cos of pi on 3, cos of pi on 4, cos of pi on 6. Did we do pi on 12? No, because we didn't need to, because now we're going to be able to do it with these formulas. Grab a scrap piece of paper. So just the back of a sheet you don't need, or if you need paper, there's over there, just a scrap piece of paper, whatever. Rip a page in half and share with a friend. We're going to play a very basic, quick little game of Jeopardy. What's the theme of Jeopardy? How is it different from other game shows? It was terrible. So how is Jeopardy different from regular game shows? Yeah, they give you the answer and you have to give the question. So I'm going to tell you that I have a fraction of 7 over 12, and I want to know what fractions did I add to get it? What fractions did I add to get 7 over 12? Is there one answer or is there more than one answer? There's more than one answer. So I could have used 6 on 12 plus 1 on 12. I could have used 5 on 12 plus 2 on 12. I could have used 4 on 12 plus 3 on 12. 3 and 4 would give me the same 2 and 5. Okay, well, what if I subtracted? I could have done 8 pi on 12 minus 1 pi on 12. I could have done 9 pi on 12 minus 2 pi on 12. I could have done 10 pi on 12 minus, I'm like hearing mumble, mumble, mumble. How long could we keep playing this game? Forever. Okay. If this is what I started with, can I reduce any of them? Okay, I wouldn't really have started with 6 on 12. What would I have started with? 1/2. So this would have been a half plus a 12th. What about this one? Can I reduce either one? Okay, the 2 on 12 would have began as 1 over 6. What about these two? Okay, I could reduce both of them. So a 4 on 12 would have been a 1 on 3 and 1 on 4. Okay, what about these guys? 2 over 3. Okay, these guys. So both could have been reduced. 3 over 4, 1 over 6. These guys. Are you still with me? Well, what if I put a pi here? How does that change things? It does change things, yes. Makes them a little more scary. What would this have done to our 1/2 and 1/12? It would have made pi over 2 and pi over 12. What would it have done with our 5 pi over 12 and 1 over 6? It would have been 5 pi on 12 and pi on 6. What would it have done with our 1/3 and our 1/4? So see, that's not that scary. All it means is I have pi's on the top. Still with me? In terms of unit circle values, do we know both of these on the unit circle? So I'm going to reject that. It's not the best answer I could get to that because I don't know what pi on 12 is. What about these? 5 pi on 12 and pi on 6. Do I know both of them on the unit circle? So that's not a great combination. What about pi on 3 and pi on 4? Well, that's a good combination I could use because I know what those values are. 2 pi on 3 and 1/12 pi on 12. No, that's not a great one. 3 pi on 4 and 1 on 6 or pi on 6? Yeah, I know both of those. That's a good combination. Do I know both of these? good combination. And if I kept going to infinity, I'm going to have some good combinations and some not so good combinations. Are you still with me? Okay. Let's do it with 1 on 12. So what could the two fractions have been? Well, it's probably a subtraction in the middle because it's hard to add two numbers and get 1. So I could choose 11 and 10. 11 on 10, if I reduce 11 on 12, is that going to work well? It's not going to give me a unit circle value. So 11 and 10 are not good choices. I could pick 10 and 9. If I pick 10 and 9, do they reduce down? So that might be a good choice. I could pick 9 and 8. Would those reduce down? And that would be a good choice. So there's no one right combination. There are good choices and there are not so good choices. I'm going to pick 9 and 8 for no reason other than I like the number 9. Okay. No, you're just watching with me. If you need to write it down, you can write it down because visual people like to write. Okay, again, it's not my only choice. I could have picked other choices that were also good. I just picked this one because I like 9. So what would the original fractions have been? Offer of 3/4 and 2/3. I feel like you're not sure on that. Okay, are you with me so far? Not the only choices. I could have had other choices that also would have given me good values down here. Okay, come back to this question with me. I don't know pi on 12. So what I'm going to do is say to myself, well, I probably added or subtracted two fractions to get pi on 12. There's lots of numbers I could choose. I'm going to choose to use 9 minus 8. Why? I just like them. So this would have reduced down to be 3 pi on 4 minus 2 pi on 3. Are you still with me? Not my only choices. I had a million other choices. I just picked these one because they reduced down to good unit circle values. I didn't pick, for example, 11 and 1 because 11 on 12 isn't going to give me a good unit circle. So I'm going to come here and say, okay, pi on 12, well, you're really equal to 3 pi on 4 minus 2 pi on 3. Those are the exact same number if I were to simplify. Are you still with me? Not the only possibility. Tons of possibilities. They're all going to work in the end. Well, this is an alpha minus beta. So what I did is I turned pi on 12 into two other angles that I'm going to now combine to make 12. Give me the other side of the cos alpha minus beta equation. Cos alpha cos beta plus sine alpha sine beta. Alpha is just the first angle that you see. So this is going to become cos of 3 pi on 4 times the cos of 2 pi on 3 plus sine of 3 pi on 4 sine of 2 pi on 3. So we didn't memorize pi on 12. All I'm doing is cheating and using values that we did memorize, and these two happen to equal pi on 12. Again, not the only choices. There's infinite amount of choices. They'll all come down to the same number in the end. This is a fraction that you're going to substitute. This is a fraction, this is a fraction, this is a fraction. Just like the first example we did. I'm looking for 4 fractions that I'm going to sub in. Well, what is the cos of 3 pi on 4? So what's the cos of the pi on 4 family? Root 2 on 2. 3 pi on 4 is quadrant 2, so the cos is negative. Cos of 2 pi on 3, so what's the cos of the pi on 3 family? Just heard 4 answers in a row. It is 1/2. 2 pi on 3 is what quadrant? 2, so cos is negative. Sine of the pi on 4 family. 3 pi on 4 is quadrant. 2, so sine is positive. And I'm just going to write it so when you look back, you know we thought about whether it was positive or negative. Okay, sine of the pi on 3 family. 2 pi on 3 is quadrant. 2, so sine is positive. I have a multiplication, then addition, then a multiplication. What do I need to do first? Do you see a theme now happening with this question at this point? Top times top, bottom times bottom. So I heard root 2 over 4 when we multiply bottom times bottom. Why is it positive? Perfect. Okay, second set of fractions. How do we add fractions? Common denominator. Again, with the alpha plus beta, it usually works out to already be common denominator. What do I do with the numerators? Smush them. Can I add a root 6 with a root 2? No. Can I combine them in any way? What do I do with them then? Put them together. That is the cos value of the pi on 12 family. And that's why we didn't memorize it, because how are you going to remember that it's root 2 plus root 6 over 4? That's the pi on 12 family. So what's the purpose of these formulas? Is it allows us to calculate values that we didn't initially memorize. They will always work like this. You're going to find whatever two fractions add or subtract to give you what you're looking for. You throw it into the formula, get the 4 fractions, and simplify. Again, these were not my only options. There's good choices and they're not so good choices. 10 and 9 were not good choices because 10 on 12, that's a lie, it does work. 11 and 1 were not good choices because 11 on 12 doesn't reduce. It's just like when we go back to the scrap paper, for 7 pi on 12, I have 3 good possibilities, and we didn't even find all the possibilities. You could use any of these, and they will all give you the same answer in the end. How you feeling? Do you feel like you need a break, or do you want to go on and do 6, which is like number 5? Break? Oh, I heard both at the same time. Let's do it, let's break. Let's do it, let's break.
How long does it break?
Well, you can start working on the homework questions. Okay, so do you want to start working on the homework questions that are like the examples we've done so far, come back after lunch and do 5 and 6?
Yeah.
That sounds great. So questions are on 560, the actual numbers are on the calendar. Again, if you come to it, you might not be able to do it because we haven't done the examples, but just do what you can. And then we'll talk again after lunch. Math is so pretty, look at that. Mm-hmm.